Hello viewers, you're welcome back to Success Arena Academy. In my previous video, we take a look at wavefronts. While in today's video, I'm going to be showing you another interesting thing with these terms that are used in describing wave. If you are new to my channel, to my viewers, please try to click on that subscribe button below and switch on the notification bell to receive new notification, and don't forget, like my video and send the video to your friend, your family. In fact, even though if you have enemy, send it to them. They will surely watch my words. They watch the video. Thank you for answering to my call. Thank you. Today we'll be looking at the terms that are used in describing wave. Now, what are the major terms that we can use to describe, that we can use to say that, this is a wave. This wave is different from it altogether. One of the terms that I want you to know is number one is the phase. Number one, the phase of the wave. Number two, the wavelength. The wavelength. Number three, we have the frequency of the wave. The frequency. Number four, we have the amplitude of the wave. Amplitude of the wave. Number five, we have the wave speed. Wave speed, and then the wave speed, the amplitude, the frequency, and then number six, we have the wave period. Or let's say the period of the wave. Period. Period of the wave. Now let's take it from the scratch. The phase. I'm going to be describing to you this phase with a diagram. As soon as I have, this is a diagram of the longitude of a transverse wave traveling all together. And I said I have the initial position here as point A. I have here as point B. Here as point C. I have here point D, point E. I have point F, point G, point, let's say, M, and here I have point O, I have point P, and here should be point Q. Now, what we said phase, are you getting something now? Two or more waves, particle, altogether, are said to be in phase if they have the same direction. Altogether, if they are traveling in the same direction, they are said to be in phase. Altogether. Now, let's take from this diagram. We want to understand what this phase simply means from this diagram. If you watch here, this is what I'm trying to say about phase. If a particle is moving along vertical direction, and the second particle is also along the same vertical direction, they are both moving along vertical direction in the same time, then we say the two particles are in phase. If they are both moving along horizontal direction in the same time, then we say the two particles are in phase. If they are moving along the south direction in the same time, they are in phase. Altogether, from this diagram, we notice that this is the starting point of the wave, which is the origin. Now, if the wave is starting here, now this is I forgot a circle. That should be number two, a circle. I'm going to explain it like that. Cycle, sorry, not cycle. Cycle, C-Y-C-L-E. Altogether, now look at this here. A circle is a complete oscillation of the wave, or complete movement of the wave. You grab. Now, if a circle can just be your normal circle, do you know that the total angle of a circle is 360 degrees, right? Now, if I cut this thing, then I have half of a circle. Now, if a wave is traveling from A to E, in this case here, the wave has just completed just only half circle from here to here. Now, when it travels from A to G, it completed a single circle. Altogether, now we can check here how many circles can we get in this wave. I have one circle and half circle that is found in this wave here. Altogether, now here, this point A, this particle at point A is at the starting point of the circle. Now, particle at point A will be in phase with particle at point G, because if we notice this, that this is one complete circle, then another circle tends to start from this point. So particle at point A and the one at point G, they are traveling together in the same direction. Both of them have the same starting point. Then we say point A and G are in phase. Altogether, particle A and particle G are in phase. The same thing applies to this. Particle B is at the start of the first circle, first half circle, while particle M is also at the start of the first half circle. We said particle B and M, look at where they are starting points, starting. B and M are in phase. The same thing applies to particle C and particle D. Particle C and D they are found at the maximum peak points of the circle altogether. So particle C and D are in phase also, while particle D and particle P, this is half of the circle at the beginning. Particle P, also this point, particle D and P are also in phase. That's what we call phase altogether. But notice that each of these particles here, okay, particle E and particle Q are also in phase. Why? This is half circle. This also forms what? Under half circle. They are in phase. Now, next thing, let's take a look at what? Wavelength. What is wavelength? We know that the particles are traveling. They are covering some distance. So I can say that wavelength is the total distance traveled by the what? Wave particle. The total distance traveled by the wave itself. Not necessarily wavelength. The wave itself, it travels from one point to another. So the total distance covered by the wave is known as the wavelength altogether. But we knew that when we are in school, then we can define wavelength as the distance between two successive crests and two successive trough. Or let me say, sorry, the distance between two successive crests or two successive crest trough in a wave. Now, what do you mean by crest? What do you mean by trough? Let me try to extend this outward a little bit. Yeah. Now, you see, the topmost part of this place here is known as the crest. This is the crest. The distance between here and here is one wavelength. Is a wavelength. Or the distance between here and here is another wavelength. This is a wavelength. But do you know that the distance between this and this form a single circle? You don't know? This and this form a what? A single circle. The distance from here to here is going to form a single circle. Are we together like this? Are we together? Now, in what way does it form a single circle? We can know that we can just use a kind of logic manner to understand. If I cut this thing like this, if I cut this thing like this is half. This half of this wave can be joined to this half here. If I combine this half and this half together, I'm sorry for this some kind of. If I bring this half here, which is here, and the half here, which is here, it will form half a circle. Combining with this circle that is here, from here to here, right? So if I combine with this circle that is here, we have what? A full circle, which is one wavelength. All together, but we can also define wavelength as the total distance traveled for complete one circle. That means distance from here to this place, this is one circle, is also a single wavelength. That is one of these things that is hidden that many students does not understand in wave. That's why it looks as if wave is difficult, because of the definition of successive crest and successive trough. Altogether, that is for wavelength. The next thing is what we call wave frequency. What do you mean by frequency? Now, it is simply the number of circles that a wave, so the number of circles that a wave will have in a specific time. Are you getting something now? Or let's say it is the number of circles per seconds. Now, the frequency of the wave is always f, which is equal to the number of circles per unit what? Time taken. Now, how many circles can that wave cover in a specific time? That's what we know as what? Frequency. Now, from here, the frequency of the wave, I can easily get here. If this is one circle, the distance from here to here can be taken as one frequency. So this is one circle. Altogether, we can get a single frequency from here to here. From here, from starting point A to G, we have a single frequency. From this G back to this place, let me say Z, this is another frequency. Now, there is time in this place. You know, it takes a wave to travel from here to this place. There is a time taking here. Let me say this is time T1, and here is time T2. Altogether. So I can easily find my frequency here. If I understand this wave here, I can get the frequency of this wave. If I know the number of circles that is found in this wave, and the time taken to cover that circle. Now, for example, total number of circles in this wave is, this is one circle, this is two circles, making 2. Number of circles here is 2, and the time taken to complete that 2 circles is needed to find the frequency. Or you can just use number of one single circle, and the time to complete that circle, you can get a frequency through that also. That is the frequency. The number of circles performed per seconds. Altogether, let me say in a unit, in a specific time. That's what we call frequency. Now, what do we now understand by amplitude? Amplitude of a wave, it simply means the maximum displacement of the particle of the medium from its mean position. Altogether, or we can say from its equilibrium position. The maximum displacement of the particle of the medium from its equilibrium position or its mean position. That's what we call amplitude. Now, don't forget I said initially, before the wave is coming, the particles of the medium are at rest. None of the particles are traveling. They are moving. They are only vibrating in their mean position, like just dancing anywhere they like in their mean position. Altogether, but these particles tend to get displaced from one point to another due to the energy that is being transferred into them. Then they start to displace from one point to another. Now, the maximum points reached by the particle of the medium before they return back, that's what we call the amplitude. Now, let's take a look from this diagram here. A particle is found in this place here at rest. They are all moving at rest in this place. When the wave struck the particle, they tend to move up. Altogether, they tend to move up in this direction. The maximum point, this is the maximum point reached by the wave. So the distance from here to here, that is our amplitude. This maximum point is my amplitude. The distance from the initial position of the wave to this point here, that is the amplitude of the wave. So we also have the same amplitude of the wave here. Look up, they have the amplitude in this place, amplitude, amplitude. Are we together? I think you are getting what I'm doing here. Now, the next one that we have is the wave speed. Before I move on to the wave speed, let me first talk about the period. Now, we'll talk about period. Period simply means time taking. It is not menstruation period though. It is the time taking though. Now, the time taking for a wave to complete a single circle, that's what we call a period. Altogether, when I was referring to frequency, I said it is the number of circles completed in a specific time. That's what we call frequency. Altogether, but the period is always the reverse of frequency, in which it is the time taken to complete a single circle. Are you getting something now? Now, here, if this is one circle, the time to take the wave to complete this circle, the time can be given in this place, time T1. That is the period of the wave. Or the time it takes the wave to complete 2 circles is also a period of the wave. Are you getting number of circles performed, the number of circles that it was completed, the time to complete that number of circles, that's the period. So far, period of the wave can be taken as time taken over number of circles to complete that period. So from here, I can have a single period also because it's a single circle, another single circle. So it depends on the number of circles. That's what you use to calculate the period that the wave has traveled. Now, the next one is now the wave speed. Wave speed. Now, what do you mean by speed? We know that speed is defined as the total distance covered per unit time or in a specific time. That's what we call speed. All together. Now, the speed of a wave also have the same definition. It is the distance traveled by the wave in a specific time, or sorry, in what per unit time. That's what we call the speed of the wave. All together. As you also know that the speed of the wave is taken as v. Abby, let me try to give you some relationship. The speed of the wave is v. The distance traveled by the wave is simply known as the wavelength. Sorry, the wavelength of the wave. altogether. So if I have a speed v, then I should be having wavelength over time taken to complete. You know that the distance traveled by the wave, the time to cover that distance is your period of the wave. Don't forget your period. That's the time to cover that distance. The period. Now I can have the period t. So my wave speed is what? Wavelength divided by the what? The period t. Altogether. Now here I want to show you the relationship that is formed between the wave speed, the wavelength, and the frequency of the wave. Now coming back to this, you know I said something earlier on that my frequency is equal to number of oscillation per unit time, and my period is equal to time taken over number of oscillation. From here, if I make my period by just saying 1 over period, I should be having 1 divided by time over number of oscillation. Then this should give rise to this. I'll be having number of oscillation over time taken. That is mathematics. Automatically, since number of oscillation over time taken is the frequency, then I can say my frequency is equal to 1 over period. Now, if the frequency is 1 over period, coming back to this, I can analyze this as 1 over period times wavelength, where my wave speed will be equal to 1 over period is my frequency times my wavelength. This is the relationship between the wave speed, the frequency, and the wavelength altogether. Now, I think we've gotten to the end of this video. Please, if you are new to my channel, as I already said, please don't forget to subscribe, like my video, share my video with your friends, and it's also with your enemy, and everyone, just share my video to them. Let them watch. All together. And also, don't forget to drop a comment for me in the comment box section below. All together, I'll be waiting to see your comment. Thank you for banking with us. Thank you.